There's a place in our universe where time stops, where light cannot escape, and where the very laws of physics collapse. A place so dense, so powerful, that even our best minds can only guess what lies beyond. It's called a black hole, and no, it's not just science fiction. What would happen if you fell into one? Would you be crushed into nothing, stretched into infinity, or somehow see the entire future of the universe flash before your eyes? Here's the strangest part. According to some real scientific theories, you might not die. In fact, you might keep falling forever. Or you might end up in another universe. This isn't fantasy. This is science, taken to the edge. And what you're about to hear may change the way you see reality itself. Hit like, subscribe, and let's go. Black holes were once nothing more than a strange mathematical prediction, a ghost in Einstein's equations. For decades, they were dismissed as theoretical monsters, too bizarre to exist in reality. And yet, today, we not only believe they're real, we've seen one. In 2019, the Event Horizon Telescope captured the first-ever image of a black hole, a glowing ring of fire surrounding an endless shadow, sitting 55 million light-years from Earth. But even with this breakthrough, we're still standing at the edge of an abyss, staring into something we barely understand. Modern physics can describe how black holes behave, but not what lies inside them. General relativity breaks down at the center. Quantum mechanics starts to unravel. And somewhere in between is a mystery so deep, so final, that it defies our grasp of reality itself. Scientists know black holes form when massive stars collapse. But what happens after that? Do they lead to other dimensions? Are they gateways? Or prisons? And more importantly, if one were close enough to Earth, could we survive its pull? Right now, black holes are silent giants, lurking in the void, invisible, but powerful. They bend time, twist space, and nothing, not even light, can escape. The truth is, black holes are the most extreme objects in the universe. And the more we learn about them, the stranger they become. This isn't just about distant galaxies or dying stars. This is about the edge of knowledge itself, and what might be waiting on the other side. It all began with a thought experiment, an idea so radical, most scientists refused to believe it. In 1783, long before Einstein or quantum theory, British philosopher John Michell proposed something unthinkable, a star so massive, its gravity would trap even light. He called it a dark star. For over a century, the idea sat in silence, too strange, too impossible. But then came Einstein. His theory of general relativity reshaped everything we knew about space and time. Just months after he published it, a German physicist named Karl Schwarzschild found a solution to Einstein's equations, one that described a point of infinite density, a singularity, surrounded by a boundary we now call the event horizon. Still, even then, black holes were treated like curiosities, wild mathematical artifacts, never expected to exist in real space. But the universe had other plans. In the 1960s, astronomers began detecting strange signals. X-ray bursts from deep space. Something massive and invisible was pulling stars apart. One by one, the puzzle pieces came together. These weren't just theoretical objects anymore. They were real and terrifying. Today, we believe there are millions of black holes in our galaxy alone, some as small as cities, others as large as solar systems. Lurking, waiting. We now know, if one were to drift into our part of the universe, there would be no warning. No time to escape. Just silence, and then nothing. Because once you cross the horizon, there's no going back. Right now, above your head, scattered across the night sky, are dozens, maybe hundreds, of black holes. They're silent, invisible, and drifting. One of them, just 1,600 light-years away, is the closest we've found so far, a stellar remnant quietly orbiting a companion star, undetected for decades. It's called Gaia BH1, and it doesn't emit any light, any radiation, nothing. You wouldn't see it coming. And that's what makes them so terrifying. Scientists estimate there could be over 100 million black holes in our galaxy alone, hidden in the dark. Each one with a gravitational pull so strong, it warps space like a whirlpool, twisting time itself. If a black hole the size of a city passed near our solar system, it could eject planets from their orbits, rip apart the asteroid belt, or even drag Earth into a slow spiral toward its event horizon. You wouldn't notice at first. Days would grow longer, strange anomalies would begin to appear, satellites failing, tides shifting, time behaving oddly, and then silence. No escape. Because once you're close enough, not even light outruns the fall. And here's the part that chills astrophysicists the most. There are theories suggesting rogue black holes, remnants of ancient collisions, may already be moving through the Milky Way. Wandering. Unpredictable. Unstoppable. We could be watching the stars while one silently approaches. Every image we capture of the sky is already old. The light took years to reach us. So if a black hole is headed our way, we may not know until it's too late. Here's the part that breaks your mind. According to Einstein's theory, once you fall past the event horizon of a black hole, you don't just get pulled in. You fall forever. Time, from your perspective, stretches, slows, stops. But for someone watching from the outside, you appear frozen, suspended at the edge, never quite vanishing. This means two things, and both are terrifying. First, time and space inside a black hole no longer follow the rules we know. The center, the singularity, isn't just a point. It's a place where the very fabric of reality folds in on itself. Gravity becomes infinite. Equations break. And second, some physicists believe that what falls in may never truly be destroyed. Information, the core of what you are, might still exist, encoded on the event horizon like a cosmic hologram. This is known as the black hole information paradox, a mystery that's haunted science for decades. Stephen Hawking once believed black holes erased everything. Later, he changed his mind. Others argue that black holes may be bridges, not ends, but portals to parallel universes, alternate realities, realms where time runs backwards. These are not science fiction ideas. They're explored at Harvard, Princeton, CERN. If true, it means a black hole isn't death. It's transformation. But into what? No one knows. No one has returned. And if they did, would they still be human? This one truth remains. If you fall into a black hole, reality, as you know it, ends, and something else begins. In recent years, our understanding of black holes has entered a new era, not because we solved their mysteries, but because we finally began to see them. In 2015, scientists at LIGO detected something humanity had never heard before: the sound of space itself, rippling. It was the first observation of gravitational waves, the echo of two black holes colliding over 1 billion light-years away. That single signal proved Einstein right, and cracked open a new way to explore the universe. Then, in 2019, the Event Horizon Telescope, a planet-sized array of synchronized radio dishes, captured the first image of a black hole. Not a simulation, not a theory, a real photograph of the unseeable. A glowing ring of gas, orbiting an abyss. And we're just getting started. New instruments like the James Webb Space Telescope are pushing further, peering into the hearts of galaxies, searching for supermassive black holes that shape entire star systems. On Earth, quantum physicists are building simulations, recreating the extreme conditions near an event horizon using light, lasers, and exotic states of matter. What they're discovering is both fascinating and unsettling. Some models suggest black holes may evaporate over time, slowly leaking radiation, fading into nothing. Others propose we might use them, one day, to travel across space or time. It sounds impossible, but so did the idea of black holes themselves until we saw one. The more we learn, the stranger they become. And somewhere, in the silence between what we know and what we fear, science is listening, watching, waiting for the next signal from the dark. But what if everything we think we know is wrong? Not all scientists agree on what black holes truly are. Some say they're not holes at all, but cosmic mirages formed by dense masses we don't yet understand. Others believe the singularity, that point of infinite collapse, might not even exist. Instead, there could be a core of exotic matter, governed by laws beyond physics as we know it. And then, there's the darker side, the unsettling theories. Some researchers suggest black holes may not destroy matter, but store it. That every black hole is a vault, holding the history of everything it swallowed forever. If that's true, they might be more than phenomena. They could be archives, or prisons. Worse, what if they're conscious? Some fringe theories propose that the universe itself might be a black hole, that everything, including us, exists inside one vast, rotating system of collapsed space. Sound insane? So did time dilation, until we proved it. But here's the cost. As we reach deeper into the unknown, the tools we build, particle colliders, gravitational observatories, quantum simulators, might touch forces we barely understand. Some physicists worry, could we accidentally create a microscopic black hole? And if we did, would we notice before it grew? Progress has a price. For every answer, we uncover darker questions. What we're chasing may change the world, or end it. Because once you open the door to the abyss, it might not close again. The deeper we peer into black holes, the more we see ourselves. These cosmic voids have forced us to rewrite physics, to rethink time, to question death itself. They've inspired new fields of science, from quantum gravity to multidimensional theories. Technologies built to study them have pushed the boundaries of computing, imaging, even communication. But every leap forward comes with a shadow. As our simulations grow more complex, as AI begins predicting black hole behavior beyond human comprehension, a new risk emerges. What if the tools we built to understand the void begin to think like it? Autonomous systems trained on black hole dynamics have already developed models we can't fully explain. The algorithms work, but no one knows why. The fear is growing. Are we building intelligence shaped by the logic of the abyss? A kind of reasoning that sees time as reversible, identity as mutable, destruction as part of creation? And if so, what happens when we apply that thinking to ourselves? Across the globe, ethical debates ignite. Should we shut down these simulations? Can we afford to stop? But the damage may already be done. Some experimental labs report unexplained anomalies, data loops, broken causality patterns, computational feedbacks that defy known physics. It's as if we've touched something that's touching back. The world, once inspired by the mystery of black holes, now fears what they might awaken, not in the sky, but in us. Not far away, but here. In every lab, in every system, in every line of code that stares too long into the dark. So now we stand at the edge. We've glimpsed the darkness, chased its echoes, touched its invisible hand. We've built machines to see the unseeable, minds to think the unthinkable. But in doing so, we've crossed a threshold. Black holes were never just distant monsters, they are mirrors. They reflect our hunger for truth, our arrogance, and our fragility. We wanted to understand them. Now we must ask, should we continue? Or stop before the questions outgrow the answers? This is not just a scientific pursuit anymore, it's an existential one. We're decoding forces that bend time, erase identity, and defy causality. And somewhere along the way, we began to emulate them in our technologies, our AI, our decisions. Do we dare evolve, knowing we may lose what makes us human? Or do we retreat, safe, but blind? Some argue, progress is inevitable. Others warn, not all knowledge leads to light. The truth is, black holes may never answer us. But the path we take in seeking them will define what we become. We're no longer just explorers. We're creators of systems we barely control. If we go further, there's no turning back. The event horizon is not just in space, it's in us. Every choice we make bends reality. Every breakthrough comes with a price. And the final question remains, will we fall into our own creation or rise beyond it? Remember the question we asked at the beginning? What would happen if you fell into a black hole? Now you know, at least, as much as science dares to tell. You wouldn't just fall. You'd stretch. You'd vanish. You might see the birth and death of the universe in an instant, or become part of something far beyond comprehension. But here's the thing that stays with me, that keeps me awake at night. It's not the fall that terrifies me. It's the fact that we're already falling. Not into space, but into knowledge so vast, so unfiltered, we can't fully grasp what it means. We've opened a door, and what's on the other side isn't just scientific. It's personal, philosophical, existential. Maybe that's why I'm sharing this with you, not just as a story, but as a warning, as a whisper from the edge. Because this isn't science fiction. It's real. It's happening. And someday, it might happen to us. So let me ask you, if you had the chance, would you look into a black hole? Would you risk everything to understand what waits beyond? Or would you walk away? Let me know in the comments. I want to hear what you think. Because in the end, maybe we're all standing at the edge, staring into something we can't quite name. And maybe, just maybe, it's staring back.